right? So we will start the 26th MCQ, right? So 26th MCQ is basically completely from physical equilibria. You need to have a general idea from this. So 26th MCQ is actually from physical chemistry, right? From physical chemistry, right? Let's dive into the question. A closed vessel contains water in contact with CO2 gas, carbon dioxide gas at 3 atm pressure. Okay, now see, we have a closed container. There you have water in liquid state. You have water in liquid state and some CO2 gas. The pressure is actually 3 atm pressure, which means 3 into 10 to the power 5 Pascal, right? That's what it means when 3 atm pressure. So atm means atmospheric pressure. If CO2 and H2O behave ideally in gas phase, underline the sentence. If CO2 and H2O, so there is some amount of H2O gas, they behave ideally, which means they don't possess any reaction in the gas phase. They can't do any reaction with the gas phase. That's what it is being said as ideal, right? In gas phase, the number of equilibria in the system, right? No harm. You know, there's a thing called solubility of gas. There's a thing called solubility of gas. Before that, you know, once you keep a liquid substance within a closed container, some amount of liquid molecules which are there with the interface of liquid and the gas, within this interface, they'll get the energy from this liquid molecule, from the other liquid molecules, by breaking their bonds, their secondary bonds. So they will be released to the gaseous phase. That's what we say boiling point. So they will be released into the gas phase. As a result, there will be some amount of water vapor also. See here, when water liquid in its liquid state goes to gaseous phase, we say that as evaporation. If it is brought to a temperature 100 degrees C, we will say them as at the normal sea level, we will say that it is the boiling point. Here evaporation has been taken place. We didn't say that there is a heat taking place over here. So therefore, as our first reaction, we have water liquid phase goes under partial reaction, goes to gaseous phase. So this process from left to right is called evaporation. From right to left, it is called condensation. That's why I have kept double arrow. So this will be under a dynamic equilibria, right? So this is under dynamic equilibria, right? Now CO2 gas is under a high pressure. It's 3 times the atmospheric pressure which is present in the environment. So what will happen is, once we increase the temperature of the gas, once we increase the pressure of the gas, the solubility of the gas to the liquid will increase. In a sense, you will get another equation. How? Once CO2 gas, once if it enters the liquid phase of water, there will be a partial reaction to form, right, CO2 gas to form H2CO3 aqueous. So this is actually a carbonic acid, right? That is actually the carbonic acid. So if you increase the pressure, obviously according to Le-Chatelier principle, it will move towards the right hand side to reduce the pressure. So here you will get this product. That's why we have the higher pressure in the system. Since this is a weak acid, carbonic acid is a weak acid. So therefore, this carbonic acid, right, will take the water molecule, goes under partial reaction. Since it's weak acid, it will form bicarbonate ion plus 1 mole of hydronium ion. There will be another dissociation of bicarbonates. So as a result, you will get HCO3 minus aqueous, which takes another water molecule within the system, goes under partial reaction, forming carbonate ion, right? Carbonate ion aqueous and a hydronium ion. Right. Now let's come to the point. Here you had a weak acid. As a result, you form an ion. So we say this one is a conjugate base. Right? Conjugate base. This conjugate base over here will again dissociate by taking water molecule. So here you will get a conjugate acid. Right? So the conjugate base is here. You have the conjugate base. Over right hand side you have the conjugate acid. Now this conjugate base, what it does is, as a fifth reaction, it takes the water molecule. So HCO3 minus aqueous will take a water molecule, right? Will undergo partial reaction, taking a H plus from the water molecule to form carbonic acid again, but the medium is going to be basic. That is why this particular substance has been come. Same way, this carbonate ion will take another water molecule, forming a bicarbonate ion, forming OH minus aqueous. So see here, we have all these kind of equilibria within this closed system. Within one of the closed system, we have around 6 reactions, right? Which means you can say this particular system, right, has around 6 equilibria. So the question that they have asked is the number of equilibria in the system. So how many equilibria we have? We have around 6 equilibria. One is caused due to the evaporation of water into the gas phase. So we can say evaporation. At the same time, there will be a condensation due to a dynamic equilibria. Due to higher pressure than the atmospheric pressure, some amount of carbon dioxide will be partially dissolved into the liquid, forming a carbonic acid. This carbonic acid will undergo a partial reaction, forming a bicarbonate ion, releasing a hydronium ion. So therefore this place is going to be acidic. Here also the same thing, bicarbonate ion will give the H plus to the water, forming carbonate ion with the hydronium ion aqueous. Since bicarbonate ion is actually a conjugate base, it takes the water again by taking out the H plus from one of the water molecule, forming carbonic acid along with the release of OH minus ion aqueous. The same case happens to the carbonate ion. It takes the H plus from the water, forming bicarbonate ions and OH minus aqueous. So this whole process can be seen during our daily life, where in fizzy drinks, right? For example, in soda water or in the cool drinks where we say like 7 Up, Pepsi and all, or in all these cases, all these equilibria will be there, right? Keep in mind, there's another extra point that I have to say. This carbonate dissociation, right? Bicarbonate dissociation, generally, if you consider the bicarbonate dissociation over here and the carbonic acid dissociation, this dissociation constant is very small. If you say this one as K1 and K2 over here, the K1's dissociation constant is very much larger than K2. So the amount of carbonate ion form is really small. So this kind of stuff they have asked in the Moratua paper. They have asked in the Moratua paper for the fifth essay, 2021 probably. They have asked regarding this thing, right? It comes under ionic equilibria under titration, most probably. They have asked in it titration. So this is the thing, the extra point that I have to say, note them down. So in future, after finishing up the MCQ parts, we will go on with the physical chemistry parts also as soon as possible, right? And we will also do some Moratua papers, supporting seminar paper and Royal College papers and all. We have some Ananda College papers, Devi Balika. So all those schools we have, MLC also. So we'll try to complete them as soon as possible. There are lots of points that have been hidden within this part. So follow the resource book also. Along with the resource book points, we will try to leave this part. So this is one of the best example for the fizzy drinks that we have consumed in our daily life. So by the way, the answer is actually the fourth answer. So this is the concept behind this MCQ. So fourth is the answer. So we'll see you in the next video for the 33rd MCQ.